Hello everybody, my name is Taylan Terzioglu and I'm a doctoral student at Istanbul Technical University in Civil Engineering Faculty, Construction Management Program under Professor Polat. And I'm also Business Development Manager at a German formwork and engineering company. And today I would like to present our paper about analysis of industrial formwork system supply chain through value stream mapping, a case study. Now I will share you my screen. As I mentioned, the title is Analysis of Industrial Formwork System Supply Chain Through Value Stream Mapping, a case study. Our case study basically is a building project in Istanbul where formwork was used. First, we will have our introduction, then we will have our description of the supply chain practices for industrial formwork systems. Then we will make our analysis of the supply chain configurations for industrial formwork systems. After that, we will make the evaluation of the industrial formwork supply chain configurations, then our conclusion. First, I would like to point out the importance of reinforced concrete in Turkey and around the world. Reinforced concrete is the most commonly used structural material. It provides more flexibility, ease of handling, and economical solutions compared to other materials. The main components of the construction of the reinforced concrete structures are formwork, rebar, and concrete. Formwork itself represents between 40 to 60% of the structure work in terms of cost and approximately 10% of the total cost of construction. There are mainly two types of formwork systems, which are traditional and industrial. The traditional are project-specific timber elements and plywood, whereas the industrial is modular elements made of different types of materials such as steel, aluminum, wooden, and polymer. I can say that the traditional formwork is project-specific, therefore, most of the materials in the traditional formwork cannot be used in other projects, whereas industrial systems are modular and standardized elements, and they can be modified and changed so they can be used in other projects. In our previous paper, we have done a similar approach, and we have analyzed the supply chains of traditional formwork and industrial formworks and compared them to each other with value stream mapping. And it was found out that traditional formwork has a high lead time and time waste, whereas industrial formwork systems reduce waste and lead time, eliminate unnecessary material movements, and also improve inventory management and a well-organized working environment. The main stakeholders in the industrial formwork supply chain are the engineer, contractor, and the formwork fabricator. As you know, the engineer does the structural design of the building, the contractor performs the construction activities, and the formwork fabricator produces. But there are also other activities where you will see where the roles and responsibilities can change. The objectives of this study is to compare the supply chains of industrial formwork systems, and second, analyzing the supply chains by value stream mapping method and determining the total waste and lead time and investigating reasons behind total time waste. In order to determine the supply chain configurations used for industrial formwork systems in the Turkish reinforced construction industry, field studies were conducted by meeting practitioners and companies involved in the industrial formwork supply chain, and the data collected from these processes were analyzed using the value stream mapping method. As you see here, these are process maps, and process maps identify the different roles and responsibilities of stakeholders in the supply chain processes. It was found out through our analysis that there are three different supply chain configurations, therefore three different process maps widely used for the industrial formwork systems. And this is the first one, the configuration 1. In the configuration 1, the contractor determines the formwork alternatives, selects the most suitable formwork alternative, and determines the initial quantities of the selected formwork to prepare the project schedule. In this configuration, the contractor and its technical team must have knowledge and professional experience with the industrial formwork systems and the local formwork markets. You can see here that most activities for formwork in the design phase is done by the contractor. In configuration 2, the formwork fabricator performs the design, scheduling, determination of the initial formwork quantities, detailing, and fabricating activities. The fabricator is regarded as an expert in the design and detailing of the formwork. The fabricator is accustomed to work with many contractors on different types of projects, and thus often has the experience needed to deal with the complexities of the project. The fabricator provides information to the contractors on which alternative formwork systems are appropriate for their projects. In configuration 2, here you see that the engineer performs the design activities for formwork. Therefore, and also does the scheduling and determination of the initial formwork quantities. In this configuration, the engineer must have the necessary experience, expertise in formwork systems, and in-house technical capacity in the formwork field, other than doing the structural design of the building. In the slide, you can see the advantages and the disadvantages and the preferences of each configuration. To summarize it, the first configuration is preferred if the contractor is able to execute the design of the formwork. Configuration 2 is preferred if the fabricator is able to execute the design of the formwork. And configuration 3 is preferred if the engineer is able to execute the design of the formwork. And in our case study, it was a building project in Istanbul, and all 3 configurations were able to be analyzed by separate orders, and the formwork quantity used in this case study was a 500 square meter wall formwork. And here in these tables, you can see the lead times, the value added times, and the wasted times and delays. And as you see here, design of the structural framing, designing of the formwork, preparing a request, detailing formwork, producing components, delivering goods to site, and assembly formwork, preparing job. Each time's work recorded and the total wasted time was calculated. As you can see, in configuration 1, the wasted time is 49%, which is very high. Configuration 2, as you remember, is where the fabricator was involved early at the very beginning with the contractor and the engineer. And therefore, as you can see here, the wasted time is only 28% of the lead time. It is greatly reduced. Configuration 3 was the configuration where the engineer performed the design activities and determining of the initial quantities for formwork. And here you can see that the total wasted time is 45%. We have also identified the reasons for wasted time for each configuration. And you can see that in general, lack of coordination among stakeholders, lack of interdependent information and data flow, lack of standardized methods for orders, inflexible production systems, inadequate inventory management, and rework due to worker mistakes are the most common reasons for wasted time. In summary, supply chain configuration 1 has a total waste of 49%, supply chain configuration 2 has 28%, and supply chain configuration 3 has 45%. Total waste percentage in configuration 2 is lower than the total waste percentages of both 1 and 3. And the total lead time in configuration 2 is only 53 days. The reasons for this improved performance in configuration 2 is the early involvement of the fabricator in the design phase, resulting in less rework in later phases and less waste. Our conclusion is that industrial formwork supply chain configurations where the formwork fabricator was involved early with the engineer and the contractor at the design phase of the project had higher performance than other supply chain configurations. Expertise of the fabricator is an important and effective in the performance of industrial formwork supply chain and is required in the design, detailing, and production of the formwork solutions. Waste can be further reduced by implementing standardized information flow, standardized solution for non-standard problems, accurate data transfer, flexible production systems, effective inventory management, and a better coordination among stakeholders. For future studies, effects of using building information modeling, BIM, in industrial formwork design on the performance of the supply chain can be investigated. Thank you for listening to me. And if you have any questions about my presentation, you can email me at this email. Thank you for listening.